recall that a function has a set of inputs called the domain, has a set of outputs called the range, and is a rule providing exactly one output for each input. So here are some special types of functions that we have studied so far. We've looked at linear functions. These are of the form y equals mx plus b, or f of x equals mx plus b, where m and b are some given numbers. We've looked at quadratic functions, which are of the form f of x is equal to a number times x squared plus perhaps another number called b times x plus another number called c. And a generalization of both linear and quadratic functions, which are called polynomial functions. So now the degree for x can be a number bigger than 2, for instance 4. So like in this example, f of x is equal to 7x to the fourth minus 8x plus 1. We've looked also, just for completely different categorization, we've looked at one-to-one functions. These are functions where, functions by the way pass the vertical line test, but these one-to-one functions are functions whose graphs also pass the horizontal line test. And now we're going to examine a new type of function altogether. It's called an exponential function. So let's, first of all, to get an idea of why we should look at this type of function in the first place, let's watch this video very quick.
Bacteria reproduce very simply and rapidly by doubling their contents and splitting in two. Just one bacterium, dividing every 20 minutes, could produce nearly 5,000 billion bacteria in one day.
So now, instead of having the number of bacteria double once every 20 minutes, as in that video, let's just say, for simplicity, that this doubling happens once every hour instead. So then, complete the following XY chart where X represents the time in hours and Y represents the number of bacteria. Let me get you started. So X is the number of hours, okay? So at the beginning of the experiment, so no time has passed, that's why X equals 0. There's one bacterium, there's one of them. And then an hour later, well, if the number has doubled, there should be a 2 here. And then if an hour later, so after 1 hour, okay, but then a second hour happens, so then 1 hour later, you should take this 2 and double it, and you should get a 4 here. Now you should pause the video, just really make this active. Take a moment, fill in what numbers you should get if there's going to be a doubling every hour. Okay, I hope you really did that. If you've unpaused now, welcome back. You should have a doubling, so you should get 8, and then a doubling again, you get 16, and doubling again, you get 32. And then at the 6th hour, there's a doubling again. There should be now 64 of these. So what is an equation in x and y that relates all the data above? You should think about this. It's real common to want to just say, oh, y is equal to 2 times x. And that works when if you take 1 and you double it, you get 2. And if you take 2 and you double or multiply by 2, you get 4. But the problem is when you take 3 and you double it or you multiply by 2, you don't get 8. You would get 6. So there's some other thing that's relating what's going on here. Squaring doesn't quite work either. It works, 2 squared is 4 and 4 squared is 16. But, 5 squared isn't 32. Yeah, so what's going on? And a hint, think about how each time here, like this number 8 is really 2 times 2 times 2. So what's a way to get it? Think carefully. Don't work too hard. But like, what's an equation that's it doesn't take a lot of writing. But what is an equation that relates this data here? That equation is y is equal to 2 to the x power. So please verify here that like 8 to plug in for the y is equal to 2 to the third. 16 is equal to 2 to the fourth. 32 is equal to 2 to the fifth, and so on. So let's take the chart that we had before and extend this for negative x values. You should fill in this chart on your own. For instance, the numbers from the previous slide will be useful when x is 0, x is 1, x is 2, x is 3, and so on. But what about when x is like negative 3? So what about 2 to the negative third? This is a good review of things from the very beginning of the semester. The hint is to use the formula a to the negative nth is equal to 1 over a to the nth. Okay, so you can even find this chart without an x and the y at the top, but you can find this data back on the day that we did exponents. So when you plug in negative 4 for x, you'll have 2 to the negative fourth, which will be 1 over 2 to the positive fourth, which will be 1 over 16. If you were to now plot these points, you'd have a graph that looks like this. You should notice here that all of the y coordinates are actually bigger than 0. So look, if this is y equals 2 to the x, okay, or f of x is equal to 2 to the x, the graph looks like this, and we should point out some key features about this is that the y-intercept is 1, okay, and that's because 2 to the 0th is equal to 1. The x-intercept, there's actually none. I know the graph looks like there's an x-intercept back here, but it's just because the drawing is just too thick, and it looks like it touches the x-axis, but it doesn't actually. Horizontal asymptote is the x-axis, in other words, the line y is equal to 0. The domain, just from the picture, so you actually have a point for any x value that you want. X can be 2, or x can be 3, or x can be 35, x can be negative 35. Any value of x is fine. There's no concern about dividing by 0. There's no concern about squaring a negative. And then from the picture as well, we can get the range. The range is actually, well, what y values do we have? All y values that are bigger than 0.